This is the first video for section 4.2a. We're going to look at distinguishing between an observational study and an experiment, and we're going to talk about the concept of confounding. So an observational study is pretty simple. It's a study where the individuals are observed. So they don't try and influence the response variable, whatever they're trying to measure. An experiment is different. They're deliberately imposing a treatment on individuals and measuring the response. So observational studies compare two groups or they examine relationships between variables, whereas experiments can be used to determine whether the treatment causes a change in the response. So an experiment is the only way you can establish a cause and effect relationship. Now, when we're experimenting, if it's not done properly, then confounding can occur, and that's when two variables that are associated and have similar effects on the response, and they can't be distinguished from each other. So let's take a look at a simple example of what confounding is. So let's say we want to know if a certain type of fertilizer works. And so we plant tomatoes in a garden that's half shaded. We test fertilizer by putting it on the plants in the sun and apply none to the shaded plants. So months later, the fertilizer plants bear more and better tomatoes. Well, can we really attribute this to the fertilizer, or is it just because of the sun? Or maybe we need the combination of both. So we're unable to determine if the fertilizer works because the fertilizer is confounded with the effect of extra sunshine. So this would be an example of a bad experimental design. Obviously, it'd be best if we split the shaded half and put fertilizer on half of the shade and no fertilizer on half of the shade, and then do the same thing in the sun where we have half of the sun has fertilizer and half of the sun has no fertilizer. Then compare within the shade and compare within the with the sun. So confounding, it's when the effects of the two variables can't be removed from each other. So let's look at this first example here, where we have the dentist in a dental clinic would like to determine if there is a difference between the number of new cavities in people who eat an apple a day and in people who eat less than one apple a week. They're going to conduct a study with 50 people in each group. So 50 clinic patients who report that they routinely eat an apple a day and 50 clinic patients who report they eat less than one apple a week will be identified. The dentist will examine the patients and their records to determine the number of new cavities the patients have had over the past 2 years. They will then compare the number of new cavities in the two groups. So is this an observational study or is it an experiment? Since nobody was assigned to a treatment, no one was told you're going to eat one apple a day or you're going to eat less than one apple a week. It's an observational study because they're looking in the past, over the past 2 years, of how many new cavities these subjects or individuals received. So this is an observational study because there was no treatments assigned. So the second problem asks us to explain the concept of confounding in the context of this study and include an example of a possible confounding variable. So two variables are confounding if their effect on the response cannot be distinguished from one another. So confounding would occur if patients who eat an apple a day are different from those who eat less than an apple a week. In this example, diet or general level of health could be confounding. One apple a day eaters may be more nutrition conscious, which explains why they eat an apple a day and why they had fewer new cavities. So a hint about how to identify or think about confounding, you can see here, is if you're asked to do this, then you're going to be expected to do two things. You're going to have to say how some variable is associated with the explanatory variable and how it affects the response. So what I did is I talked about how 1 apple a day eaters, that group, they could be more nutrition conscious. So they just might be healthier in general. And them being more nutrition conscious explains why the explanatory variable might be true. They're eating an apple a day, and it explains how the response variable is affected. In this case, the response is their dental health, or the number of new cavities that they had. So there could be other examples of confounding that you could think of, but this was just a good example that I wanted to use. So last question, if the mean number of new cavities for those who ate an apple a day was statistically significantly smaller than the mean number of new cavities for those who ate less than an apple a week, could one conclude that the lower number of new cavities can be contributed to eating an apple a day? So basically, if the differences are big enough, can they say that eating an apple a day causes less cavities? And the issue is, this is an observational study. It is not an experiment. We can only establish cause and effect with an experiment. And we're going to talk later about what statistically significant means. Only experiments can establish cause and effect relationships. So take a second, see if you can do this practice problem here, and then we'll jump to the next objective from this video, which is to identify experimental units, explanatory and response variables, and treatments in an experiment. The treatments are the condition that is applied to the individuals in an experiment. Could be a combination of multiple explanatory variables, and individuals could be people, or they could be tomato plants like we saw earlier. Experimental units, those are the people or the things that are going through the treatments. Factors is another name for an explanatory variable, and factors or explanatory variables might have different levels. And this example problem will help you understand what levels might look like. So what are the effects of repeated exposure to an advertising message? The answer may depend on both the length of the ad and how often it is repeated. An experiment investigated this question using 120 undergraduate students who volunteered to participate. All subjects viewed a 40-minute television program that included ads for a digital camera. Some saw a 30-second commercial, others saw a 90-second commercial. The same commercial was shown either 1, 3, or 5 times during the program. After viewing, all the subjects answered questions about their recall of the ad, their attitude toward the camera, and their intention to purchase. So we are asked to identify the experimental units or the subjects, the explanatory variable, and the response variables of the treatment. So the response is the variable that we're measuring. The explanatory variable is the one that explains the outcomes for what we've measured. And the experimental units are who or what is being is undergoing the treatment. So let's start with the experimental units. In this case, the 120 undergrad students are the experimental units because they're going through the experiment to determine how well this ad worked. So I think the response variable is generally the easiest one to move to next. The response variable is easiest to do next because it's what you are actually measuring. And if you think about it, they're trying to see if the ads work, and they're measuring how well they recall the ad, what their attitude is about the camera, and if they intend to buy it or not. So the explanatory variable is, what are they doing to see how well this works, or to see how well they recall, or what their attitude is about the camera. They're using the explanatory variable, which is the length of the ad as well as the repetition. So the length of the commercial is one of the explanatory variables, and the number of times it's repeated is another. When we're thinking about length, there are 2 levels of the length because the commercial could show for 30 seconds or 90 seconds. Number of repetitions was 1, 3, or 5 times during the program. So there are 3 levels. And so finally, the treatments are going to be the combination of the different explanatory variables. So there were 3 levels of number of repetitions and 2 levels of the lengths. So there will be 6 total different treatments. So you can see there are the 6 different treatments, and it's just the combination of the explanatory variables.